Hello, in this lecture we will find out the radius of the red semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. We also know that side AB of triangle ABC equals to 3 units. And also side AB is tangent to the red semicircle at point B, and also line segment AE is tangent to the red circle at this point, point E, and line segment DC equals to 1 unit. And actually the red semicircle is inscribed by the triangle, and as I already said, it has 2 touching points with the triangle. One point is point B and the other point is point E. So we want to find out the radius of this red semicircle. So first of all, I will present to you a new rule. Rule number 1, or you can call it also two tangents theorem. So rule number 1, or two tangents theorem, states that the lengths of two tangents of two tangents from a common external point to a circle are equal. So I will read the two tangent theorem, or rule number 1 again. Two tangent theorem states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1, or two tangents theorem? The meaning of two tangents theorem is that if you have a circle, this blue circle, and you also have an external point, point P. This point, point P, is an external point to this circle. Why point P is an external point of this circle? Because of the fact that point P is not located inside this blue circle, nor on this blue circle, therefore it is located outside the blue circle, therefore it is defined as an external point of this blue circle. So if from the external point P, we will draw two tangents to this circle. So the first tangent will be this tangent, and we will define the touching point between the first tangent to the blue circle as point A, and then we will draw a second tangent to this blue circle and the touching point between the second tangent and the blue circle will be defined as point B. So, according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So the length of the first tangent, that is starts from point P and ends at point A, is actually PA. It equals to PA and the length of the second tangent to the blue circle, it is actually PB, and according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So we have two tangents, tangent PA and tangent PB, that exist from a common external point, from the common external point P to that circle, and according to two tangent theorem, the lengths of those two tangents are equal. That is to say, PA equals to PB. So, according to two tangent theorem, whenever you draw two tangents from a common external point of a circle to that circle, then the length of those two tangents will be equal. In this case, PA equals to PB. Okay? So that is the meaning of two tangents theorem. The length of two tangents, in this case, is PA and PB, from a common external point. So the common external point is point P to a circle. We draw the two tangents from a common external point P to the circle. The touching point of the first tangent with the blue circle is at point A, and the touching point between the second tangent and the blue circle is at point B. So, according to two tangents theorem, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. Okay? So, that is actually the meaning of rule number 1 or two tangents theorem. And we can actually implement rule number 1 or two tangents theorem in our drawing, because in our drawing we have the external point A. Point A is an external point in relation to the semicircle because it is not located inside the semicircle nor on the red semicircle, but it's located outside the semicircle. Therefore, it is defined as the external point of this semicircle, and from the external point, point A of the semicircle, we have two tangents to this semicircle. The first tangent is tangent AB. You also know that the size of AB is 3 units. So the first tangent is tangent AB, and the second tangent to the red semicircle is tangent AE. And according to rule number 1 or two tangents theorem, whenever you draw from an external point of a circle two tangents to that circle, then they will be equal to each other in their sizes, in their depths. That is to say, AB equals to AE according to rule number 1 or two tangents theorem. Okay, AB equals to AE, but we know that AB equals to 3 units, so AB equals to 3 units. So from this equality, we will derive that AE also equals to 3 units. Okay, AE equals to 3 units. So we can write here that line segment AE equals to 3 units in its size, in its length. Okay, and we will define the center of the semicircle as point O. Again, point O is the center of this red semicircle. Then we will join together points O and E by a straight line. Actually, line segment OC is the radius of the red semicircle. Why? Because it starts from the center of the semicircle, that is to say from point O, and ends at point E, that is a point on the semicircle itself. Therefore, line segment OE is defined as the radius of this red semicircle. We will call the radius of the semicircle R. Therefore, OE will be equal to R, the radius of the semicircle. And from the same reason, also line segment OD is the radius of the semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point of the semicircle itself. Therefore, line segment OD is the radius of this semicircle, so it equals to R. And from the same reason, also line segment BO will be the radius of this semicircle, so it equals to R. So in the next step, I will present to you a new rule, rule number 2, and we will implement rule number 2 in our drawing. So rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. So rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this blue circle and the center of this blue circle is at this point, we'll define the center of the semicircle as point O, and we have a tangent to this circle. Actually here AB or tangent AB is tangent to this blue circle at this point. We will define the touching point between tangent AB and the blue circle is point M. Actually, point M is the point of tangency. Point M is the point of tangency of tangent AB with this blue circle. Again, point M is the point of tangency of point AB, of tangent AB with this blue circle. Then we also have a radius that starts from point O and ends at point M. So this radius is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius, that is to say, this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle, it equals to 90 degrees. So, a tangent to a circle, that is to say, tangent AB, is perpendicular to the radius drawn to its point of tangency. So this radius OM, it is drawn to the point of tangency, that is to say, it is drawn, this radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency. Therefore, the tangent AB, this tangent is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle is also a right angle, it equals to 90 degrees. So according to rule number 2, whenever you have a radius that is drawn to the point of tangency, like in this drawing, this radius is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency, of tangent AB with this blue circle, then the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so that is rule number 2, and we will implement rule number 2 in our drawing. in our drawing we have tangent AC. Tangent AC is tangent to this red semicircle at point E, so point E is the point of tangency. Of tangent AC with this red semicircle. Again, point E is the point of tangency of tangent AC with this red semicircle, and we have this radius OE. It is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees because the tangent AC is perpendicular to this radius, and this angle will be also equal to 90 degrees. You see that the tangent is perpendicular to this radius, so those two angles will be equal to 90 degrees according to rule number 2. Why? Because the radius OE is drawn to the point of tendency, therefore those two angles will be equal to 90 degrees. Okay? So actually we see that angle OEC, this angle is a right angle. It equals to 90 degrees. If angle OEC is a right angle, then triangle OEC is a right triangle because it has one angle that equals to 90 degrees. So actually the green triangle is a right triangle. Okay, the green triangle is a right triangle. Triangle OEC, the green triangle is a right triangle. So we will focus on the right green triangle, triangle OEC. Okay, so in the green, this green right triangle, triangle OEC, again on the right green triangle, triangle OEC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? And the hypotenuse in the green triangle, it is actually the side that is in front of the right angle, and the side that is in front of this right angle is angle is side OC. So OC is the hypotenuse of the green triangle. So the square of the hypotenuse is OC squared. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC squared equals to OE squared plus EC squared. I'll repeat again. In the right green triangle, triangle OEC, According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. Okay, here we will define the side of EC as x, that is to say EC equals to x units in its size. But what is OC? OC, the size of side OC, or the length of side OC, you can see from the drawing that the size or the length of side OC of triangle OEC, it equals to R plus 1. Okay, again, OC equals to R plus 1. If OC equals to R plus 1, then OC square will be equal to R plus 1 square. Okay, so OC equals to R plus 1 square, and all equals to OE square. As you can see from the drawing, OE equals to R. OE equals to R is the radius of the red semicircle. If OE equals to R, then OE square will be equal to R square plus EC square. EC equals to x unit in its size, so EC square will be equal to x square. So in total, we got that R plus 1 square equals to R square plus x square. Here we will open the brackets of equation number 1 of this side of equation number 1. R plus 1 square, it is actually R square plus 1 plus 2R, according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB. Okay, so R plus 1 square equals to R square plus X square. So here we have R square in both sides of equation number 1, so we subtract R square from equation number 1, so R square will get cancelled, and what is left after we cancelled R square, what is left, it is actually 1 plus 2R equals to X square. So we found out that according to equation number 1, 1 plus 2R equals to X square. Okay? 1 plus 2R equals to X square. So in the next step, we will focus on 2 triangles. On the right big triangle, triangle ABC, and we will also focus on the small right green triangle, triangle OEC. And we will actually prove that those 2 right triangles similar to each other. Triangle ABC and triangle OEC, the green right triangle, triangle OEC. I'll repeat again. We'll focus on the right big triangle, triangle ABC, and the right small green triangle, triangle OEC. So on these two triangles, we know that those two angles are equal to each other, they are both right angles. So we can write down that angle ABC, this angle in triangle ABC, angle ABC equals to angle OEC in the green triangle, triangle OEC. And both angles are right angles, that is to say they are equal to 90 degrees. Okay? So angle ABC in triangle ABC equals to angle OEC in the green triangle, triangle OEC, and they are both equal to 90 degrees. Okay? And we actually have also here a common angle. This angle is a common angle. It belongs to both triangles, to the big triangle, triangle ABC, and angle C also belongs to the small green triangle, triangle OEC. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Angle C equals to angle C is a common angle. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. So angle BAC equals to angle EOC according to third angle theorem. I will write it down. Angle BAC in triangle ABC is equal to angle EOC in the green triangle, triangle EOC, and they are equal to each other according to third angle theorem. I will repeat again. Angle BAC equals to, in triangle ABC equals to angle EOC in the green triangle, triangle EOC, and they are equal to each other according to third angle theorem. So, what is third angle theorem? Third angle theorem states that or rule number 3 or third angle theorem so third angle theorem states that if two angles in one triangle congruent. To two angles. In another triangle, then the third pair of angles must also congruent. So I will read third angle theorem again. Third angle theorem, rule number 3 states that if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 or two angle, or what is the meaning of rule number 3 or third angle theorem? The meaning of third angle theorem is that if you have two triangles, we have triangle ABC, this is triangle ABC, and we have also a second triangle, triangle DEF. This is triangle DEF. And in those two triangles, we have two pairs of angles that congruent. The first pair of angles that congruent are those angles. This angle equals to alpha, and this angle also equals to alpha. This is the first pair of angles that congruent in those triangles, and we have also second pair of angles that congruent. The second pair of angles that congruent are angle beta equals to angle beta. So if this is the situation that we have two pairs of angles that congruent, like in this drawing, then the third pair of angles must be also congruent. Those two angles that are the third pair of angles must also congruent to each other. Suppose that this angle is gamma and this angle is theta, then according to rule number 3 or third angle theorem, angle gamma equals to angle theta. That is the meaning of the third angle theorem. If you have two pairs of angles that congruent in two triangles, then the third pair of angles must be also congruent. That is to say, those angles must be also equal to each other. Okay, so we will actually prove that those two angles congruent, or they are equal to each other, and we will prove it by the rule that states that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees in this triangle. That is to say, alpha plus beta plus gamma equals to 180 degrees. Okay, so according to the rule that the sum of the angles in any triangle equals to 180 degrees, then in triangle ABC the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees. In triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. In triangle DEF, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Okay, it is true in any triangle, and especially in those two triangles, triangle ABC and triangle DEF. So here we will subtract equation number 2 from equation number 1, and we will get that alpha minus alpha equals to 0, beta minus beta equals to 0, and gamma minus theta equals to 180 degrees. Minus 180 degrees is 0. So we found out that according to equation number 3, that gamma minus theta equals to 0. 180 degrees minus 180 degrees is 0. So we will add to equation number 3 theta, and we will get that angle gamma equals to angle theta. So we actually proved that angle gamma equals to angle theta. That's what we wanted to prove, that angle gamma equals to angle theta. So we actually proved that if we have two pairs of angles that are equal in two triangles, then the third pair of angles must be also equal to each other. So if we have two pairs of angles that are equal in two triangles, then the third pair of angles must be also equal, or the third pair of angles must also congruent. Okay, we proved that angle gamma equals to angle theta, and in this way we actually proved that the third angle theorem is indeed true. Okay, so we return to our original drawing. We actually proved that all three angles of the right big triangle, triangle ABC, congruent to all three angles of the green right triangle, triangle EOC. Therefore, we actually proved that triangle ABC is similar to triangle EOC. Okay, so we actually proved that the right big triangle, triangle ABC, is similar. Triangle ABC is similar to triangle EOC. according to angle similarity rule. I'll repeat again. We prove the triangle ABC is similar to triangle EOC according to angle similarity rule. So what is angle similarity rule? Actually, if you prove that three angles of one triangle can go into three angles of another triangle, then you prove that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to the green triangle EOC, we will derive that AB over AC equals to OE over OC. I will repeat again. From the fact that triangle ABC is similar to triangle OC, we will conclude that AB over AC equals to OE over OC. Okay? But what is the value of AB? The value of AB is 3 units. It is given us in the question that AB equals to 3 units, so AB equals to 3. What is the value of AC? AC, you can see from the drawing that the hypotenuse AC equals to 3 plus x. Okay, the hypotenuse AC equals to 3 plus x. So AC equals to 3 plus x. And repeat again. AB equals to 3 units, AC equals to 3 plus x units. And what is the value of OE? All equals to OE. You can see from the drawing that OE equals to R. It is the radius of the red semicircle. OE equals to R. Here. OE equals to R. And what is the value of OC? The value of side OC of the green triangle OEC, you can see from the drawing that it equals to R plus 1. OC equals to R plus 1. So actually in total we got that 3 over 3 plus x equals to R over R plus 1. Here we will cross multiply equation number 2 and we will get that three times R plus 1 equals to R times 3 plus x. Okay, we cross multiply equation number 2 and we got that 3 times R plus 1 equals to R times 3 plus x. Here we will open the brackets in both sides of equation number 2 and we will get that R plus 3 equals to 3R plus R times x. So we open the brackets in this equation number 2, and we got this expression. Three r plus 3 equals to 3r plus rx. So here we have 3r on both sides of the equation, so we will subtract 3r from equation number 2, so 3r will get cancelled, and what is left after we cancelled 3r? What is left is it is actually 3 equals to r times x. So here we will divide this equation number 2 by x. So why it is allowable to divide the equation by x? Maybe x is 0, and if x is 0, then you are not allowed to divide anything by 0. But as you can see from the drawing, x, it is actually side EC of the green triangle, triangle EOC. So it must be a positive number. It can never be 0. It is a side of the triangle. A side of a triangle can never be 0. For that reason, you can divide equation number 2 by x, because it can never be 0. So we divide equation number 3 by x, and we will get that r equals, according to equation number 2, r equals to 3 over x. So we found out that the radius of the red semicircle equals to 3 over x. So the only thing that is left to find is to find the value of x. And we have already found out, according to equation number 1, we know that 1 plus 2r equals to x squared. That is what we have already found out in equation number 1. Okay, so here we will substitute r in this equation number 1. We will substitute r in this equation number 1 by 3 over x, because r equals to 3 over x according to equation number 2. Okay, so we'll do it now. So in equation number 1, we will get that 1 plus 2 and r, according to equation number 2, equals to 3 over x, all equals to x squared. Okay, here 2 times 3 is 6, so we write it down. 2 times 3 is 6. So we will get that, according to equation number 1, 1 plus 2 times 3 is 6, 6 over x equals to x squared. So we found out that according to equation number 1, one plus 6 over x equals to x. Here we will multiply equation number 1, this equation, by x, and we will get that one times x is x, 6 over x times x is 6, x squared times x is x cubed, So here we will subtract x from this equation number 1, and we will get that x cubed minus x equals to 6. So here we will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. We know that minus 2x squared plus 2x squared equals to 0. So it is allowable to add 0 to any equation. So we will add this expression that equals to 0 to equation number 1, and we will get that x cubed, and we will add 0 to this equation number 1, or 2x squared minus 2x squared plus 2x squared that equals to 0. And here we have minus x minus 6 equals to 0. Okay, I will repeat again. We actually added to equation number 1 this equation minus 2x squared plus 2x squared, that is 0, and it is allowable to add to any equation 0. Therefore, it is allowable to add this expression to equation number 1, that is 0. Okay, so I will copy again equation number 1. According to equation number 1, x cubed minus 2x squared plus 2x squared minus x minus 6 equals to 0. Okay, I actually copied again equation number 1. So here actually minus x equals to minus 4x plus 3x. Okay, minus x equals to minus 4x plus 3x. So we will substitute minus x in equation number 1 by minus 4x plus 3x. Because minus 4x plus 3x equals to minus x. So we'll do it now. We will get that x cubed minus 2x squared plus 2x squared, and instead of minus x we will write down minus 4x plus 3x minus 6 equals to 0. Okay, so here we will divide equation number 1 to 3 parts, and we will take a common factor from each part. So this will be the first part, this will be the second part, and this will be the third part. Okay, I'll repeat again. We will divide this equation number 1, to 3 parts. 1, 2, 3, and we will take a common factor from each part. Okay, so part number 1 is x cubed minus 2x squared, and the common factor that we will take from x cubed minus 2x squared is x squared. So x squared is the common factor of this expression. What is left after we took x squared as a common factor from x3? What is left is actually x. And what is left from minus 2x squared after we took a common factor of x squared? What is left? It is actually minus 2. So in total, we found out that x cubed minus 2x squared equals to x squared times x minus 2. We repeated the same process for expression 2. Expression 2 is 2x squared minus 4x we will take a common factor of 2x out of this expression. So what is left from 2x squared after we took 2x as a common factor? What is left? It is actually x. And what is left from minus 4x after we took 2x as a common factor? What is left? It is actually minus 2. So in total, we found out that 2x squared minus 4x equals to 2x times x minus 2. We'll repeat on the same process from expression 3. We will actually take a common factor from 3x minus 6. Actually, the common factor that we will take from 3x minus 6 will be 3. So what is left from 3x after we took 3 as a common factor? What is left? It is actually x. And what is left from minus 6 after we took 3 as a common factor? What is left? It is actually minus 2. So in total we found out that 3x minus 6 equals to 3 times x minus 2. Okay? So actually, because of the fact that in expression number 1, this expression equals to this expression, we'll substitute this expression by x squared times x minus 2, and we'll substitute the second expression 2x squared minus 4x by 2x times x minus 2, and we'll substitute the expression of 3x minus 6 by the expression of 3 times x minus 2. Okay? And we know that the sum of those three expressions, in total they are equal to 0. Okay? So we will substitute expression number 1 x cubed minus 2x squared by x squared times x minus 2. Then we will substitute expression number 2, 2x squared minus 4x squared by 2x times x minus 2. And we will substitute expression number 3, 3x minus 6 by 3 times x minus 2. And this expression, those three expressions together equals to 0. So in total we got this equation number 1. So here we take a common factor of x minus 2 from equation number 1, and we will get that so x minus 2 is a common factor of equation number 1. So what is left from x squared times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from this expression 2x times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 2x. And what is left from expression number 3, 3 times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 3, and all equals to 0. So in total we got this expression that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we will have two solutions that are possible for this equation number 1. Either x minus 2 can be equal to 0, then 0 times anything will be equal to 0, or the second option is that x squared plus 2x plus 3 equals to 0, and then if it equals to 0, then 0 times anything will be equal to 0, and then 0 equals to 0. So we write down the two possible solutions to this equation number 1. The first possible solution is that x minus 2 equals to 0. That is the first solution that is possible for equation number 1. And the second solution that is possible for equation number 1 is that x squared plus 2x plus 3 equals to 0. Okay, so we will focus on the second possible solution, solution number 2, and we will find out the value of x. This is a quadratic equation, and the general formula for a quadratic equation is that ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. Ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this general quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to a special formula for x. The following formula for x. X actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. We will find out the value of x by using this special formula for x. Okay? We'll use this special formula for x in order to find out the value of x. So in our specific quadratic equation, that is to say x squared plus 2x plus 3 equals to 3, the coefficients of this quadratic equation are as follows. Here a equals to 1, b equals to 2, and c equals to 3, so I will write it down. A equals to 1, b equals to 2, and c equals to 3. So we will put the data inside this equation for x in order to find out the value of x. Okay, so here x will be equal to minus b equals to 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, and c is 3. So it is 4 times 1 times 3 over 2a. 2 times a is 1, so 2 times 1 is 2. So in total we got this expression for x. So the value of x will be equal to minus 2 plus minus square root of 4 minus 4 times 3 is 12 over 2. Okay, so actually we found out that x equals to minus 2 plus minus root of 4 minus 12 is minus 8. Minus 8 over 2. We found out that the value of x is equals to minus 2 plus minus square root of minus 8 over 2. But because of the fact that a negative number doesn't have square root, minus 8 doesn't have a root, therefore this quadratic equation has no solution. So this possibility is not correct, so we'll cancel this possibility because a square root of minus 8 doesn't exist. Therefore we have no solution to this quadratic equation, and the only solution that is possible for equation number 1 is that x minus 2 equals to 0. Okay, so we found out that x minus 2 equals to 0. That is the only solution that is possible for equation number 2, that x minus 2 equals to 0. X minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. So we actually found out that x equals to 2. And according to equation number 2, we have already found out that the radius of the semicircle equals to 3 over x. So we can substitute x in equation number 2 by 2 because x equals to 2. So we'll do it now, and we will get that the radius of the semicircle equals to 3 over x. X is 2, so it is 3 over 2 units, or we can present it as 1.5 units. 3 over 2 is 1.5 units. Okay. The radius of the semicircle equals to either 3 over 2 units or it equals to 1.5 units. I will repeat again. The radius of this red semicircle R equals to either 3 over 2 units or it equals to 1.5 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the semicircle and we have triangle ABC. It is a right triangle. AB equals to 3 units. Line segment DC equals to 1 unit. Angle ABC is a right angle. Therefore, triangle ABC is a right triangle. And the red semicircle is inscribed by triangle ABC. And we want to find out the radius of this red semicircle. So, first of all, I presented to you rule number 1 or 2 tangents theorem. According to rule number 1 or 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. So, what is the meaning of rule number 1 or 2 tangents theorem? The meaning of rule number 1 is that if you have this circle and we have external point P of this blue circle, and from the external point P we will draw 2 tangents to this circle. The first tangent is tangent PA and the second tangent is tangent PB. Then, according to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So, whenever you draw from an external point of the circle, that is to say from point P, 2 tangents to the circle, then the length of those 2 tangents will be equal to each other. That is to say PA equals to PB. Okay? So the lengths of 2 tangents from an external point P to a circle are equal to each other. That is to say PA equals to PB. Actually, we can implement rule number 1 or 2 tangents theorem in our drawing, because we have external point A. Point A is external point in relation to this red semicircle, and from point A we have 2 tangents to this red semicircle. The first tangent is tangent AB and the second tangent is tangent AE. And according to rule number 1 or 2 tangents theorem, the lengths of those 2 tangents are equal to each other. That is to say AB equals to AE. Okay? But we know that AB equals to 3 units. Therefore, from this equality we will derive that AE also equals to 3 units. Okay, then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle, the center of this circle is at point O, and we have tangent AB. Tangent AB is tangent to this blue circle at point M. Point M is the point of tangency of tangent AB with this blue circle. And we have this radius, the radius OM, is drawn to the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So I'll repeat on rule number 2 again. According to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its points of tangency. This radius, the radius OM, it is drawn to the point of tangency, that is to say to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So we will actually implement rule number 2 in our drawing. We implemented rule number 2 in our drawing because here we have tangent AC is tangent to the red semicircle at point E. Point E is the point of tangency. And we have the radius OE that it is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency. Therefore, the tangent AC will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. And because of the fact that angle OEC equals to 90 degrees, then triangle OEC is a right triangle. The green triangle is a right triangle. And we can implement the Pythagoras theorem in the green right triangle, triangle OEC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. OC equals to R plus 1. OC equals to R plus 1. So OC square is R plus 1 square. OE equals to R, so OE square is R square, and EC equals to X according to our definition, so EC square is X square. So in total we got that OC square equals to OE square plus EC square, that is to say R plus 1 square equals to R square plus X square. Here we open the brackets in this side of equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R. And all equals to R square plus X square. Here we have R square in both sides of equation number 1, so we subtracted R square from equation number 1, and we got that 1 plus 2R equals to X square. So according to equation number 1, 1 plus 2R equals to X square. Then we focus on the big right triangle, triangle ABC, and on the small green right triangle, triangle OEC. And we actually prove that those two triangles similar to each other. Why? Because we have angle ABC equals to angle OEC equals to 90 degrees. Those two angles are equal to each other, they are both right angles. And we also know that this angle is a common angle, it belongs to both triangles, so we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Angle C equals to angle C is a common angle that belongs to both triangles. And also angle BAC equals to angle EOC. Angle BAC equals, those two angles are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay, so what is the meaning of third angle theorem? The meaning of third angle theorem is that actually if we have two triangles, triangle ABC and triangle DEF, and in those two triangles we have two pairs of angles that congruent. This is the third pair of angles that congruent. Those two angles are both equal to alpha. This is the second pair of angles that congruent to each other. Those two angles are both equal to beta. Then if this is the situation that we have two pairs of angles that congruent in two triangles, then the third pair of angles must be also congruent. That is to say, according to third angle theorem, angle gamma equals to angle theta. And we actually proved that the third angle theorem is true by the rule that says that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees. That is to say alpha plus beta plus gamma equals to 180 degrees. Likewise, the sum of the angles in triangle DEF equals to 180 degrees. That is to say alpha plus beta plus theta equals to 90 degrees. Alpha plus beta plus theta equals to 90 degrees, to 180 degrees. Then we subtract equation number 1 from equation number 2. alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we got that gamma minus theta equals to 0. We added theta to equation number 3, and we found out that angle gamma equals to angle theta. So we actually proved that if we have two triangles with two pairs of angles that congruent, then the third pair of angles must be also congruent, that is to say, angle gamma equals to angle theta. Okay, so we will repeat to our drawing. We actually proved that all three angles of the right triangle ABC congruent to all three angles of the right small green triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. Therefore, from the fact that triangle ABC is similar to triangle OEC, we will conclude that AB over AC equals to OE over OC. Again, AB over AC in triangle ABC equals to OE over OC in triangle OEC. Okay, AB equals to 3, AC equals to 3 over X, OE equals to R, and OC equals to R plus 1. We cross multiplied equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. We opened the brackets in equation number 2, and we got that 3R plus 3 equals to 3R plus RX. We subtracted 3R from equation number 2, and we got that 3 equals to RX. If 3 equals to Rx, then R equals to 3 over X. We divided equation number 2 by X, and we got that R equals to 3 over X. But we have already found out that 1 plus 2R equals to X squared. So we can substitute R in equation number 1 by 3 over X, because according to equation number 2, R equals to 3 over X. So we substituted R by 3 over X, and we got this equation. 1 plus 2 times 3 over X equals to X squared. 2 times 3 is 6, and we got this equation that 1 plus 6 over X equals to X squared. We multiplied the equation number 1 by X, and we got that X plus 6 equals to X cubed. Here we subtracted X from equation number 1, we got that X cubed minus X equals to 6, then we subtracted X from equation number 1, and we got that X cubed minus X minus 6 equals to 0. Then we added 2x squared, we added minus 2x squared plus 2x squared to equation number 1, that is 0, and we got this expression. Then we substituted minus x by minus 4x plus 3x, and we got this expression. And then we took a common factor from, we divided the equation number 1 to 3 parts, and we took a common factor from each part, and we got these 3 equalities. After we took the common factor from those 3 parts, we got these expressions, and we substituted those 3 expressions by these 3 expressions, and we got this expression number 1. Here we took a common factor of x minus 2, and we got this expression. Here we have 2 solutions to this equation number 1, either x minus 2 equals to 0, or x squared plus 2x plus 3 equals to 0. Here we solve this quadratic equation. This quadratic equation doesn't have a solution because a square root of minus 8 is not defined, so there is no solution to this quadratic equation, and the only solution that is left is that x minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. Okay, x equals to 2, and we already found out that r equals to 3 over x. So we will substitute x in equation number 2 by 2, and we will get that the radius of the semicircle equals to either 3 over 2 units, or it equals to 1.5 units. I will repeat again that the radius of this semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay, thank you very much.